Howdy, folks. Let's install some shims. This is Snark with Snark's Domain. Hopefully you guys are having a great day. My day's going pretty good. I wasn't sure if I was going to be able to do anything today or not. I'm back on call for work now for the next 10 or 12 days. It sounds like the weekend will be slower, which is good. I've got a few things I gotta, non-putty related things I gotta catch up on. Yeah. And then it'll be off to work for little bits here and there for the next basically 2 weeks, and then I'll be back home again. And my got some visitors from out of town coming, so Cloud Yak, good to see you. Yo, I love the idea of shims. Really interested to see if there's a practical difference between copper and aluminum. Yeah, I'm kind of excited too. I did test both combos before on test bench 1, but that testing was not accurate enough to show a difference if there was one, because they seem to get the same result. I used TGPP10 with copper and TGP-10 with aluminum, and they both had the same memory junction temperature. So yeah, we'll see if we can find a difference this time around with better testing. And I mean, we'll further refine that on test bench 3 eventually as well. But that'll be some time before I would ever get to shims on test bench 3, since that's going to focus on phase change initially. And then we'll go through the putties with that, and then after that we'll eventually get to shims. That's shims on test bench 3 is going to be like a next year sort of thing. We've definitely got to do all the phase change materials first on there. But yeah, this Laird T-Putty stuff, my early thoughts on it, having not seen the numbers yet, other than doing some like rough calculations, it's going to be really good. I expect it to do some stuff at the top of the chart, and actually I like it. It's a nice softness. Hey Mitch, how's it going? If you can manage to make the charts look like T-Sharp's idea, it's going to be so good. I'm definitely going to do that. That's the plan for sure. We're going to make the charts a little bit easier to look at. So I want to point out something, and this is a sign of like an ideal soft putty. So let me just focus that. It's not perfect. Okay, so you guys see this putty here, right? Let's zoom in a bit more, just why not? That's okay, we're at max zoom. She ain't got no more power. See how it looks narrow, but you can see that outline of the film that it left? What that means is that it pulled up the putty, because it's soft. It's got the stalactites and stalagmites. That's a good sign. That's what you want putty to do. Most of the better putties do this. Some of the really soft putties obviously also do this, but they lack in performance. Some of them do anyways. So this is a good, well-balanced putty. This means that if you overcompress it by just a tiny bit during during assembly, and then it like springs back, it's going to stick to both surfaces and spring back. Now most putties can, even the stiffer ones, can do this a little bit until the seal breaks and then air can get trapped behind. Obviously this wasn't going to stretch out like hot cheese on a pizza, but we did get some that went what looks like an inch or two stretch. So anyways, it's good putty. That's what I like to see, and yeah, it does perform good. Maybe I should put this in another container. Like, I just want to reuse it. This stuff's fine. It's not even dirty. Yeah, we're just gonna put it in the container, and I'll just know that I'll probably put some of this in another video card pretty quickly for longevity testing. We'll also do... I'll have to see if I have enough Honeywell. Realistically, I have to buy more Honeywell. So HT10,000, I'll have to look into that. I would like to do longevity testing on both of these, the 910 and the HT10,000. We'll probably do Laird T-Putty 607 in a card as well. But relatively minimal cleanup for the bulk of the putty, at least in its fresh state, right? Over time that might potentially stiffen up a bit, but let's get this. I've got a bunch of things I want to do, so let's see if we can get most of them done. We'll get this cleaned up. I mean, for today, we'll definitely just leave the chart as it is for the 910 results, and I'll have to work on a new chart design. Maybe later today. We'll see. You might have time. Just a wee bit more. We should be clean enough. So I've got some sheets of Honeywell PTM 7950 on the way, the big sheets. And we've got two different thicknesses. They're coming from CapLink, one of the first official distributors for Honeywell. They sell all sorts of Honeywell stuff. You can get, 5 or 6 different PCM lines there. They've got like the 5000, the 7900 series. There's a other series as well with like lower thermal conductivity, and of course our favorite 7950. And they do sell it in 0.2 and 0.25. They also said they sell it in 0.3 millimeters, but they didn't have any of that in stock at the time. And if I wanted some of that, they would have to order a bunch of inventory to be able to sell me one. So I decided just to stick with the two they've got, and we'll see. I mean, I have no doubt that there are 2 different common thicknesses out there already. But there are some that think that 0.2 millimeters means you're getting fake PTM 7950, and I'm quite confident that's not the case. But hey, let's put it to the test and see, and let the results hopefully figure things out for us. So let me just grab some gloves here momentarily. The screws, that looks relatively safe over there. Before we get too far, we're gonna make sure these shims are nice and oil free. Just put that there for now. That looks like a good spot. Yeah, it's a drying rack. You know, there's airflow. It's good. What about you guys? You guys have any good plans for the weekend? We've got some thermal putty jobs happening right now in people's laptops in the Discord, so hopefully they're doing good with the phase change bit and the reassembly. Still has some cotton stuff. I'm going to use a paper towel here. You guys hadn't noticed, I like it when the mat is fairly clean when dealing with putty. The cleaner the putty is, it's at least 5 frames per second, I figure. Let's use it from this one. Okay, we're gonna just gonna apply something like that. This is the excess is all gonna squish out anyways, which we'll trim up in a few moments. But we're just gonna get this in place. Cloudyak, you're packing everything up to move to Hawaii? You're moving to Hawaii? Oh my gosh. That is awesome, dude. Oh, CodeString, how's it going, man? Not a lot, mostly the same old here. Yeah, man. I hear that. But Cloudyak, you're moving to Hawaii. Packing servers and other computer equipment all this weekend. Ooh, that's a big move. Man, next time I'm in Hawaii, I'm gonna give you a shout. Depends which island. We were going to go potentially to Maui next time. We've already been to Oahu before. I'm assuming you're going to Oahu. Out of Hawaii back to the mainland. Oh, you're moving from Hawaii. Man, I missed the out part. There's a little, on OBS, there's a little heart in the bottom right hand corner of the chat, and it makes it really hard to see some of the words sometimes. So, well, it looks like I'm gonna miss you in Hawaii because we're not going anytime soon. We went a few years ago, and it was good. Okay, so what I'm doing is, let's zoom into this here so you guys can see a bit better. Kid says, hey dude, I have a question. I have 20 grams of Upsar and UX Pro Ultra thermal putty and will soon get 50 grams of UTP-8. Can I put that UX Pro on the VRAMs on my 3070 Ti and the UAP on the rest of the elements? You can, and UX Pro is pretty... It's a stiffer putty, but if you're using it in a GPU like this one, and if you've got a 3070 Ti, you're probably going to have similar gap thicknesses for your VRAM, I'm pretty sure. So, yeah, you could totally put the UX on the VRAM and then UTP-8 everywhere else. There's nothing wrong with doing that. Rather than, and you... Actually, 50 grams. Honestly, man, you've got enough to do the entire card in UTP-8 if you want to. You could go that route. Or you could mix and mingle. It's they're basically the same. They're basically the same performance. With UTP-8 just being maybe, what was it, half a degree better? Something like that. It's not much, if anything. Okay, can you guys see that? When I'm pressing, I'm like pressing and holding. And you can gradually see it like growing. And then I'll like shift it around if I think I've got it off center. Putty does compress, and it compresses slowly when you're going for the ultimately thin gap thickness that I'm going for. Just trimming the edge there, just to make sure it looks good. We might do more compression. I just want to take a look, make sure it's still centered on the VRAM. This stuff is pretty easy to work with for trimming. I mean, you guys can see that I'm not struggling with it at all. It doesn't leave that much of a mess, if you ask me. But for folks coming from pads, I know it's a bit daunting having what looks like bubble gum on your video card. I mean, that's, if only it was bubble gum. I don't think we're going to test bubble gum. That would be risky and irresponsible of me. But it'd be fun. We would only do that if we were going to fully retire the card. Even then, I don't think I would. I don't think I would do that to this card. It deserves better. It's been through a lot. Okay, that one's good. This one needs more compression, I can tell just by looking at it. So I'm pressing pretty firmly. Shims are risky that way. Only go start using shims if you're comfortable with the risk. Like this is not something I would recommend just everyone start doing. We're doing it for testing, but to be honest, I prefer just putty for the most part. With the exception of a 3090, I think the back plate, not even the core side, I think the back plate of a 3090 would be worthwhile just doing those shims even, and leave the core side alone. And the reason you'd leave the core side alone, even though you could improve those ones, is they already have access to the cooler. And when you use shims, it is harder to get pore contact. But on the 3090, the main thing that matters is getting the VRAM cooled on the back plate. And there is a strip of of putty that go, or pads that go from the PCB to the cooler, but they're less critical. I might even install some of these leftover aluminum nitride shims, which I've got a bunch of these. I might install those on the back side of my 3090, and there's no electrical conductivity, so it's pretty safe to use those ones. Otherwise, you know, the core side VRAM is going to be chilly, which is fine, and the back plate would be toasty. So, all right, let's wipe up the core here real quick. We're going to apply some MX4, and then we'll do some more putty after that. You're getting Upsiren PCM1 for the GPU die. Nice. Maui is awesome. Currently on Oahu, and it's an awesome place. Nice. Mitch, I got a heat issue. Bought a Sedali SSD cooler. I've seen those ones. Is that the one with the 2 copper pipes and like those little notches in the, what I assume must be aluminum cooler? The one that like looks really cool and makes you think of like cars and mufflers for some reason. But you have a heat issue because one of the TR one was too big for the space it was going in. It's right between the GPU and CPU cooler, so when they get hot, it gets pretty toasty. KDiz, what about longevity? Will UX Pro last longer than UTP-8 on the GPU? If anything, I think thermal transfer will remain good either way. I think UTP-8 will remain softer longer than UX Pro. UX Pro is already a stiffer putty, so I don't think you're going to get the same. I don't think it'll be as soft as long. And how long each of these putties lasts actually still remains to be seen. There's 2 different metrics. There's it's maintaining its softness and it's maintaining its performance, and we care mostly about the performance. Like if it turns into basically a solid pad. Not that it's going to turn into a pad, but that's not really an issue in the long run, as long as it still transfers heat well. But my gut says UTP-8 is going to maintain its softness and be like reusable if you had to repaste the die, which you shouldn't have to repaste. And it's good that you've got a 3070 Ti with GDDR6X, because you'll be able to see if the temperatures degrade, you know, like 1, 2, 3 years from now. And you'll just want to do like a baseline test and maybe even like record it in HW info. And then if you ever think you're getting bad temperatures, you can do a test again. I would use a fixed fan speed for recording a baseline. That way it's less variables that you're having to account for. Now we are going to get a little bit of putty here. See, Soflane or Sophiane. Hopefully I'm not saying your name wrong. Welcome to the stream. Hi, I applied PTM 7950 a week ago, and my GPU temps are good, but the CPU is still hot. So, is there any chance that my CPU temps will improve after more weeks? I'm assuming you're talking about a laptop, probably. Well, first of all, are you using putty? Or are you using thermal pads if it's a laptop? Well, the reason I ask is that you probably should be using putty, hopefully, because thermal pads are not going to unlock the ultimate like good cooling ability that a phase change like Honeywell PTM 7950 will have. Because pads don't like to compress further than a certain amount. Like it's, you know, softer pads, they can press a bit more. You might open up the back under, like the cooler, you might open up the bottom cover and lay your laptop, which I'm assuming it is a laptop, down on a flat, sturdy surface and just apply pressure to where the putty is, or the pads are, to try and help it compress a bit more. And then see if you can get a little more mounting pressure on that PTM. Because PTM can only become thin if it heats up and has pressure applied at the same time. Now, if you have thermal pads instead of putty, then you're going to have a really hard time getting it to be super thin. Yeah, putty's probably the perfect pairing. That's a lot of P words. But that was not intended to say lots of P words. Okay, let's trim it up here. What time we got? We have 4:06. I think I've got enough time to crunch data. If I get this buttoned up fairly quickly here. Doing shims does take a bit more of a finesse to it. Even myself, right, I can mess up the compression part. But, and I think that shows in the results too. Like if you look at the ETC hash results versus the Furmark and then the Kapow results, I generally, like, because we're trying to measure the effectiveness of the shims and not necessarily if I'm getting the perfect like core contact and application each time, which I'll try for, obviously, but I can't always guarantee that with shims. The ETC hash test is probably the most accurate of the three. Because it's not core intensive at all, and we're really just getting the load on the memory itself. So just keep that in mind if you look at the comparison charts once we get more shims in place, that it's Mostly, I'm trusting the ETC hash test to show us a good comparison of different products. Alright, we've retouched up all the TGPP10, that white stuff. We got shims in place, MX4 on the core, and we are going for touchdown. Can find the mounting holes. Okay, we got the mounting holes. We're going to start the screws in. It's just crazy how the residual heat coming off the back plate would have this big of an impact. I'd probably be able to fix it with the vertical mount or Movo with it. Yeah, I really like the vertical GPU mounts now. Partially because we're putting less pressure on the male PCIe connector of the card, which I've watched a number of videos now from like Northwest Repair where they've like cracked that off on like AMD 7000 series, or even I think there was some like 4090s that also cracked, even just in shipping. And at least I think one or two of them was in shipping. And it's with these, like, I don't know how many layers these PCBs have now. Is it like a 12 layer, 8 layer, or something like that? It's a lot of layers. That's hard to work on. I just don't like the fact that GPUs are so bulky and heavy nowadays. And they apparently have to be for pumping like, what, 600 plus watts sometimes? There's like VBIOSes out there for 666 watts for those 4090s. That's a lot of watts. Okay, so I've got all the screws started. None of them are tight. And these are below the surface of the back plate. I'm going to flip this around and I'm going to apply pressure basically evenly, left and right. And I'm just going to hold it there. Master Trolleus, your CPU temp will get better, but you may need to add more pressure, yeah, just to make sure you get good contact. And if there are pads, then that also could be holding you up from the true potential of PTM, right? The PTM wants to get super thin, all the way down to, what, 1.5 thousandths of an inch? We're talking about like machine shop tolerances for cutting steel. Pretty thin. And pads have a way of like propping up the cooler and like preventing it from applying all of its force down on the where it needs to go. Yeah, I'm pretty happy with that. Let's zoom in here so you guys can see what I'm doing for the so it's made good contact. And you can see it's starting to squish out that little bit of excess, but we've pretty much nailed the mount. And I'll know if I have half decent core contact here pretty soon. I'll just press down a little bit more. Yeah, okay, it is a good point. Most people do ignore the fact that during gaming, the heat coming from the GPU, especially through the back hole, increases the temps of the RAMs. I had to turn down a notch on my RAM OC because it was unstable during gaming and in summer. Yeah, those summer temperatures don't help us out any, do they? Alright, let's check the screws. None of those are protruding. Good to go. We'll do the star pattern. Sofian says, yes, it's a gaming laptop with a high TDP CPU. Use UTP-8 on the VRMs, and I'm sure that the mounting pressure is very good. Maybe I should wait for more heat cycles. Yeah, I wouldn't go and jump to liquid metal just yet. I would give it a good burn-in. If you're willing to do like a good 2-hour burn-in, loading up the CPU and the GPU at the same time, you could do like a combination of like Furmark and Cinebench Multi, and then just control your fan speed and try and keep the temps up around, 75 to 80 Celsius. That'll help the phase change melt, and the hotter you go, the faster it's gonna, like the lower the viscosity and the easier it will flow out. And then the mounting pressure should have a better time of squishing it out. I assume all of your screws are fully tightened. You definitely want that to do that as well, just to make sure you're getting all the mounting pressure possible. And you're also going to want to consider your fan speeds and see where they're at, and see if you could compare that to before. Obviously, it's hard to go back in time and see what the fan speed was, but if you have a screenshot of like HW info, that's usually the easiest to go back and look. Again, hey, how's it going? Good to see you. Welcome to the stream, as always. Kids, I bought RAM fan cooler from AliExpress to help the issue. Yeah, I remember back in the DDR2 days, I bought some OCZ voltage extreme RAM, and that stuff was it liked the voltage for sure. You had to like choose between using the 3.3 volt rail with a power supply where you could actually adjust the voltage with those little like knobs on the back of the power supply, or switch to the 5 volt rail to feed the VRAM, because you could feed up to, well, I'm pretty sure I went up to what was it, 3.9 volts on it to get pretty good overclock. And I just took two, I want to say 80 millimeter fans. I'm pretty sure it was. And I made a little like custom bracket that held them off to the side, and that seemed to work pretty good. Out. Yeah, I'm gonna set that to the side for now. Hopefully that's in a good spot. And let's quickly crunch the T-Putty data, because I think you guys are probably excited to see that. Let me just open up and close a couple things here. All right, let's go to the second screen. Close that. Okay. Oh, you know what I forgot to open? Of course, I always forget to open something. Test bench 2. VRAM TIM chart. And the calculator sheet. All right, let's make some copies here. etc hash. I'm gonna try and do this quickly because I am have tons of time. I've got enough time to do this, but not tons of time. I'll go pick up my daughter. Let's put in an entry. Laird.ca. Laird T-Putty 10. Is it? It's August 29th? Yeah, 2024. All right, so we'll select, we'll change the reference sheet that it's grabbing from. Escape, select all, Control F, Control V, data, yeah, it'll pull from there. All right, let's do that for mark as well. And kapow. ETC hash looks relatively stable for the VRAM T delta. Again, all of this is going to get a lot more accurate on test bench 3. Looks like we had a connection drop or something happen there, so we won't use that. We'll use hour 2. Paste values. Yeah. Two. Oh, I just had this one running overnight. So you guys can see the variance between each chunk of like hour. I'm hoping that's gonna like shrink substantially on test bench 3. We're gonna have much more stable pressure. Oh, it looks like there was some drop, something happened there, but this is all good data. Yeah, we'll use hour 2. Let's see. Computer is slow right now. I'm trying to work faster than it wants to. This stuff's pretty good. Let's see how it stacks up on the chart. So we've got Laird T-Putty 910. Browser.ca. ETC hash 182. Well, let me just double check the fan speeds here. 2592. Yeah, that's good. Voltage or watts are good. 2592. Watts are good. 2592 average and 309. Yeah, watts are good. Just to make sure I'm not getting bad data here. Core looks good. Hotspot, it's fine. Yeah, that's pretty decent. Okay, let's place these results. 50.27. Interesting. I thought it was going to actually I mean, no, that's actually right up with the other ones within half a degree or so. It's not too bad. Well, I was expecting it to be like right at the top for some reason. 50.3. B7.4. Yeah, which is right up there. Let's see. It's got really good softness, I'll say that. So, it'd actually be interesting to see what the core. Yeah, really good core, really good hot spot. Nice. It's good putty. Let's be honest, anything at the near the top of the chart is a good performing putty. It doesn't have to be in first place. Most of them are pretty close right up at the top anyway, so 58.4. I mean, on this sheet it's doing even better. Maybe it's compressing better? I wonder. Hot spot. That's pretty much in line, 39.2. Either way, really great putty. I would not hesitate to use it if you were needing to use a bulk amount of putty somewhere, and if you needed it to be from a large, well-established manufacturer. That being said, you know, there's Laird, there's Honeywell, Fahonda, and Pencham, and Hountonseye, right? Those are all well-established manufacturers. And then there's the smaller ones, like the Upsirens, the CX H1300 stuff. I'm not even sure who makes that. But yeah, lots of different options. Master Trolleus says, oh, kids, yeah, those DDR2 could get hot. They definitely could. Well, you bought one from the Alzai company, but you're changing to 60 millimeter fans from Noctua. Yeah, those should hopefully give you a bit more performance, and also maybe even a little quieter. Master Trolleus, I remember when ultra expensive RAM bus was the top stuff on Pentium 4 Prescott. You mean Prescott? Willie met CPUs. You had 32 gigs back then? Are you kidding me? Dude, that's I mean, it's a decent sized flex now. You had 32 gigabytes of RAM on DDR2. I had I had 1 gigabyte. I was rocking two 512 megabyte sticks of OCZ VX 3200. I burned that out after a few years because I was pushing it way too hard. I think it was up at around like 4 volts, and yeah, they made it no problem for VX 4000. They actually upgraded my RAM because they didn't have any VX 3200 left in stock. And then sadly, OCZ doesn't make RAM and stuff anymore. They kind of like discontinued everything and sold off to, I can't remember who owns them now. But maybe it's because guys like me were breaking their really awesome enthusiast level RAM, and it was costing them too much money. Like, I'm sorry, OCZ, I should not have RMA'd the broken RAM, but it does have a lifetime warranty. So I don't know, what are you supposed to do? Yeah, I've got all these saved. Okay, guys, I think let's take a look here. We got them all in place. Yeah, like, I don't think these charts are the final say at all right now. They're not, because we're going to be improving the quality and the accuracy of the test bench. So if we're being honest, this 910, I mean, it's actually placing really good on the core intensive ones. The memory specific one is it's down here, but I wouldn't hold that against it. And like, I would assume, I don't know, my gut says it's just going to end up higher somehow on test bench 3, but I don't know. I don't control the results. The results just sort of, they spit out how they do, and we've got to place them on the chart as the results dictate. So yeah, but I wouldn't be surprised if we're going to see some stuff like shuffle around probably when we go to test bench 3, right? The NVIDIA cards, they only show memory junction temperatures in 2-degree increments, which if you guys look at, see this right here, this is what I'm talking about. See how it's like basically a flat line and has little like things jumping up occasionally that approximately 2 degrees. That's the 2-degree resolution of the VRAM on the card. Makes testing and trusting the results to be final really hard. And that's why I think things will shuffle around. The AMD card we're moving to has a resolution of 0.1 degrees, so it's 20 times better on being logged by HW Info than this NVIDIA card or any of the AMD 7000 series. So yeah, we'll see if things move around. Should be interesting. Oh, your IETS GT600 dropped by 10 to 12 degrees Celsius. Pretty noisy, yeah, for sure. Well, it's good to have good headphones, right? Especially for the family as well, so they don't have to listen to us going shooty shooty bang bang. So you're not just getting extreme cool airflow, but you're also getting rid of the ball cheese dust and funky gremlin hairs. Yeah, you gotta, you know, it's like a Hoover vacuum, but the opposite. Yeah, this stuff is expensive right now, but I think I didn't even look at the listing long enough to realize I was buying the 30cc container. And I'll be honest, when I was looking at Laird T-Putty 607, I'm pretty sure the prices for a 75cc cartridge or a 30cc cartridge were like not far off from each other, which is crazy because the 75 is giving you 2.5 times of the 30. But if you were buying putty in bulk, the cost is going to be a lot different. Also, if you're an existing customer for like Laird products or like at Mauser or any other, or DigiKey, it's also on DigiKey, like you guys are going to have a built-in discount that like the small consumers like me won't have. So it's a great putty, and it'll be interesting to see head-to-head with Honeywell HT10000 how they do on Test Bench 3. I'd expect them to be a little bit closer even in performance. So let's be honest, they're very close in performance even now. It's pretty good. But anyways, guys, I've got to go. Thanks for tuning in for the stream. I hope you guys have a great rest of your day, and maybe if I have time later on, I'll do another stream tonight, hopefully. Not to test another product out, but maybe swap some GPU fans and maybe work on some Test Bench 3 stuff if my power supply arrives. Hopefully that happens today. So you guys have a great day. Thanks again. Bye.